6 companies, 1 empire. Elon Musk's factories churn out the same batteries that will power your car, your robot, and the first Martian cities. In just 2 years, humanoid Optimus robots built on Tesla's production lines will outnumber workers. In 5 years, those robots, each guided by Grok AI, could be constructing Mars habitats and farming red dust. But how is this convergence possible? And what happens when the very technologies running your home also control the future of life on another planet? The answer begins deep inside the assembly lines, where the separation between Earth and Mars is already vanishing. Inside the Fremont and Giga, Texas factories, rows of 4680 battery cells roll off the lines, each a cylinder of stored power, 46 millimeters wide and 80 millimeters tall, holding 22 amp-hours of energy. These cells are the backbone for everything: Model Y sedans on California highways, Optimus robots assembling parts, and the first Martian power grids. By September 2025, Tesla crossed the milestone of 100 million of the 4680 cells produced, with a run rate near 17 gigawatt-hours a year. Yet that is only a fraction of what the machines can deliver. Giga Texas alone holds enough installed capacity for 100 gigawatt-hours, running at 17% of its potential. Production speed is surging, driven by a breakthrough in dry cathode manufacturing. A new binder mix, PTFE blended with PVDF and PEO, lets electrodes form in 3 passes instead of 10, tripling throughput and slashing costs. The price per kilowatt-hour has dropped below $115, with early batches of fully dry cells aiming for $95 per kilowatt-hour. In-house 4680 cells are now the cheapest battery Tesla has ever built, undercutting even long-time suppliers. These cells flow straight into the next frontier: humanoid robots. Optimus Gen 3, standing at 173 centimeters and designed to lift up to 30 kilograms, is built around the same battery core as Tesla cars. By the end of 2025, the target is 1,000 to 5,000 units deployed for internal testing. Each robot is expected to cost $20,000 to $30,000 at mass production, with ambitions for 1 million units a year at Fremont and 10 million a year in Texas. For now, engineers and technicians work side by side with the first Optimus units, training them for the repetitive, precise, and often dull tasks of factory life. Today, it is assembly lines. Tomorrow, it is construction sites on another planet. In June 2025, Tesla activated unsupervised full self-driving in Austin, Texas. For the first time, a geo-fenced region allowed vehicles to operate without human intervention, relying entirely on the autonomy pipeline built over years of real-world training. This milestone wasn't just about cars navigating city streets. The same vision system that interprets stoplights and pedestrians in Austin now guides Optimus robots through factory floors. Neural networks trained on millions of miles of driving data are repurposed to help humanoid robots distinguish between a wrench and a circuit board, or to navigate crowded assembly lines. The transfer isn't superficial. Both Tesla vehicles and Optimus rely on a shared architecture. Camera arrays feeding sensor data into high-speed onboard computers, processed by neural networks refined on Dojo supercomputers. When full self-driving reached unsupervised status in Austin, it proved that AI could handle unpredictable, unscripted environments. That confidence unlocked the next phase, deploying the same autonomy backbone in robots that must operate with minimal oversight, whether on Earth or preparing for Mars. This software bridge means every improvement in vehicle autonomy immediately strengthens the robot fleet. The autonomy pipeline is no longer siloed. Every mile driven, every object recognized, every edge case solved for cars becomes a lesson Optimus can use. The result is a feedback loop. Data from roads and factories flows into the same AI core, accelerating progress. The line between vehicle and robot intelligence blurs, setting the stage for a unified intelligence layer powering the next era of automation. Grok is measured in silicon and teraflops, not headlines. In February 2025, xAI released Grok 3, trained on 200,000 GPUs inside the Colossus supercomputer. This single facility, built in Memphis in just over 4 months, draws more than 150 megawatts and orchestrates one of the densest GPU arrays ever assembled. By July 2025, Grok 4 arrived, posting a 45% score on the Human Last Exam, a benchmark designed to test reasoning beyond rote memory. XAI's valuation surged to $113 billion after a $10 billion funding round, with Saudi Arabia, Nvidia, and AWS among the backers. Colossus is not standing still. Construction began on Colossus 2, a planned 500-megawatt data center expected to house up to 800,000 GPUs. The stated ambition is to double compute capacity every 2 months, targeting 64,000 GPUs dedicated to Mars simulation and robotics by mid-2026. This exponential scaling is not just for chatbots. The same neural core, Grok, now trains Tesla full self-driving Optimus robot cognition and the systems that will optimize Martian colonies. Every improvement in Grok's reasoning flows directly into the autonomy of vehicles, robots, and future off-world settlements. The Empire's cognitive engine is no longer theoretical. It is operational, accelerating, and designed for universal deployment. Nolan Arbor's story begins in a hospital room, paralyzed from a diving accident, unable to move or speak. In January 2024, he became Neuralink's first human patient. Surgeons implanted a coin-sized device in his motor cortex. Within weeks, he could move a cursor across a screen using only his thoughts. By the end of the PRIME study, Arbor was typing 8 words per minute, up from 0, reclaiming a piece of daily life many take for granted. Over 2,000 cumulative days of device use have now been logged across 12 participants, with no major device-related complications reported. Arbor plays video games, chats online, and controls digital devices with a speed and fluency that once seemed impossible. The technology is advancing quickly. A new trial launching in October 2025 aims to convert thoughts directly into text for people with speech impairment, while the first international expansion to the United Arab Emirates is scheduled for 2026. Neuralink's roadmap calls for 20 to 30 new implants in 2025, scaling to thousands of applicants as surgical robots streamline the procedure. Dual implant capability allows upgrades without removing the original device, and protocols now prevent air pockets that once limited implant longevity. Scaling is already underway, but the real leap comes from integration. Arbor's neural signals can, in principle, direct not just software, but physical machines, Optimus robots, even those on Mars. Direct brain-to-robot control is no longer science fiction. As the technology matures, the boundary between intent and action narrows. Human cognition becomes a command interface for a new class of machines, closing the loop between thought and the physical world. Starship construction yards in Boca Chica work around the clock, assembling the fleet for the first uncrewed Mars campaign. The plan calls for a logistics surge, 5 test launches between late 2026 and 2027. Each Starship loaded with Optimus robots, life support modules, and autonomous tunnel boring machines. If these initial missions land safely and orbital refueling succeeds, SpaceX will greenlight a wave of 20 Starships in 2028 and 2029. Each vehicle delivers up to 150 metric tons per flight, stacking up to 1 million tons of cargo on the Martian surface over the next decade. The first ship, christened Heart of Gold, touches down at a site selected by Grok simulations for stable terrain and subsurface access. Optimus units are the first to step onto the regolith, unloading supplies and scouting for underground lava tubes. Boring Company machines begin carving out the first habitats beneath the surface, where radiation and dust storms cannot reach. Engineers describe it as the largest off-world construction effort ever attempted. It is an industrial relay where robots, not humans, are the advanced team. Every launch, every ton landed, brings the vision of a 1 million-person colony closer to reality. XAI's timeline for superintelligence is measured in years, not decades. By the end of 2025, the company puts the odds near 80% that artificial intelligence will surpass any individual human. Within 2 to 3 years after that, Musk projects a 60 to 70% chance that Grok will outthink all of humanity combined. By 2030, XAI claims there is a 95% probability that artificial intelligence will exceed the capabilities of every living person on Earth, scientists, engineers, and policymakers included. Yet these forecasts come with a warning. Musk does not shy away from the risk. He estimates a 10 to 20% chance that superintelligence could end civilization if alignment fails. The remaining 80 to 90%, in his view, is a shot at an amazing future, a golden age of abundance, scientific breakthroughs, and optional work. Artificial intelligence safety researchers, however, caution that no one has yet proven how to align a system of this scale. One leading expert puts it bluntly: "We are entering the riskiest decade in human history. The countdown has already begun, and the outcome remains uncertain." Today, Musk's unified tech stack is not just a vision, it is operational, shaping everything from factory floors to rockets bound for Mars. As AI and robotics scale at record pace, the line between science fiction and reality blurs. The question now is, who gets to write the next chapter?